So we are going to be talking about Part 3 in Lab 5 about op amps. In Part 3, our goal was to design an audio mixer that mixes two songs together. We chose to mix famed French singer Edith Piaf with notorious urban poet Rick Ross. And so Thomas is going to show you about the circuit we designed to do this.
Our circuit was designed so that it uses two different inputs, which are the audio signals, one from a computer, one from a phone. And the audio input voltage runs into a potentiometer. One of them is 0 to 50 and one of them is 0 to 100. And these potentiometers, as you will see later, are used so that we can adjust the signal coming from each power source, which is kind of its proportion of the mix. We used additionally another resistor running from the V out source back to the VN negative, which gives us our negative feedback. This resistor has a value of 5.57 kiloohms. The main part of this mixer is the op amp, which is where the actual mixing of the signals occurs. It also amplifies the signal, and then the output of that goes to the speaker. This op amp is powered by a plus minus 15 volt power source.
So, using the oscilloscope, we measured the maximum amount of voltage Vn that will be provided by Thomas's computer and Thomas's iPod. And for both of these, we found that the maximum voltage is 2 volts. Using the equation for V out, which is equal to RF over R1 times Vn plus RF over R2 times Vn, and using Vn is equal to 2 volts, which we measured, and RF to be the 5.57 kiloohms Thomas mentioned, and the potentiometers of R1 and R2, we found a range for our V out. Using the smallest amount of resistance in the potentiometer, which would be 1 kiloohm, we plugged that in for both R1 and R2 and solved for the lowest V out, which would be 0.3342 volts, and using the largest resistance for the potentiometer, which for the first potentiometer would be 50 kiloohms, and for the second 100 kiloohms, and found that this V out, the maximum V out, will be 22.28 volts. So we're going to show you how our circuit works. We're going to play around a little bit to show you the effects of changing the resistances in the potentiometers. I'm going to change one of the resistances. So here, we can hear that Rick Ross is the dominating song. And Edith Piaf is completely blacked out. So do the reverse.
Reverse that.
We can only hear Edith Piaf. And that is our circuit. For Part 4 of Lab 5, we are to make a comparator. And a comparator is a circuit with a binary output. And Thomas is going to walk you through our design for the comparator.
In this circuit, it's got a binary output, as Sarah mentioned, but that works from two different inputs. The first input, V minus, is a 5 volt power source that runs into a 5 kiloohm potentiometer. The second input is an iPod playing music, which is a 2 volt power source running through a 2.5 kiloohm resistor. We simply used a potentiometer for the sake of accuracy. Both of these run into an op amp, which is powered by a plus 15 minus 15 power source, and the output from this runs through a LED light to ground. When the binary part is on, it turns the light on. When it is off, the light is off. And since it is a variable input from the 2 volt, the 2 volts the max, it's a variable input, so that's why you see it changing.
So as you can see on the oscilloscope in the circuit, you can see the LED light flashing as the signal changes. And on the oscilloscope you can see the changing as well. So we're going to pause it on the image that we think simplifies. It's a good image right here. So as you can see, the output is the blue square wave, and the input is the yellow. And when V plus is greater than V minus, because it is a binary comparator, the output will be 15 volts, and this results in the light going on in the blue square wave.
The blue square wave, as you can see, is a flat top. It's either flat top at about 15 volts or 0, and that's, as a binary, it's either yes or no, on or off, and there's not really a middle ground, which is why the slope is so steep between the two. It's just connecting the 2 bonds.
So, as you can see, our circuit is working as desired. The LED light flashes as the signal changes. And so, in the next image we're going to show you, we understand that the oscilloscope provides us with a reverse mirror image. So that is the next image you will see.